Now in this example, I have a double replacement reaction. I have magnesium hydroxide reacting with hydrochloric acid to form magnesium chloride and water. And the problem that I'm trying to solve is if I need to produce 47 grams of magnesium chloride, how many grams of hydrochloric acid would be required to make the reaction work? Now, when I'm starting a stoichiometry problem like this, the first thing that I need is a balanced chemical equation. And I have my blocks here showing the entities. The blues are magnesiums, whites are oxygens, red are hydrogens, and the green are chlorides. And you might notice that the reaction isn't balanced. For example, I've got one chloride on the left, I've got two chlorides on the right, and I've got one oxygen on the right and two oxygens on the left. So I need to balance my reaction first. So one thing that I need is more chlorides on the left, so we can add another HCl, and that gives this guy a coefficient of 2. And I need more oxygens on the right, so I can add another water, and that will give the water a coefficient of 2. And now my equation's balanced. I've got 1, 2, 3, 4 hydrogens on the left, 1, 2, 3, 4 hydrogens on the right, 2 oxygens on the left, 2 oxygens on the right, 2 chlorines on the left, 2 chlorines on the right, 1 magnesium on the left, 1 magnesium on the right. Now, if I'm concerned about the mass of HCl and the mass of magnesium chloride, I don't really need to consider the other things. Once I've balanced, I'm done thinking about these other entities in the reaction, and these are the guys that I care about. So what do I need to do? The mass of magnesium chloride and the mass of hydrochloric acid won't be the same. Now you might say, oh, it's not going to be the same. This is going to have twice the mass of HCl as the magnesium chloride that you produce. And you're starting to think on the right track, but that is not correct because this coefficient doesn't apply to the mass. It only applies to the number of moles. And that's because if you look at your molecules, there are twice the number of molecules that have to react. There are 2 HCl's that react every time one magnesium chloride is produced. But the magnesium chloride is a lot heavier than each of these HCl's. Each magnesium chloride weighs 35 plus 35 plus 24. Each mole of these weighs 94 grams. And each mole of these only weighs 36 grams. So there will be twice the amount of something, but the thing that there will be twice the amount of is numbers of moles. Each one of my blocks here represents 1 mole. So what I need to do, and I'll represent this onto a box diagram, I need to first figure out for these 94 grams of magnesium chloride, how many moles would that represent? Right, and I can use my molar mass in order to do that. That'll be my first step. Then, once I know my number of moles of magnesium chloride, I can use the ratio of the coefficients 2 and a 1 to figure out how many moles of HCl will be required. And once I know the number of moles of HCl, then I can figure out the mass of HCl. And that's going to be my third step, which is going to require me to use the molar mass formula again. So the things that I'll need to do here in step 1, I'll need to use my molar mass formula. Step 2, I'm going to use the mole ratio. And then in step 3, we're going to need to use the molar mass formula again. So let's take these steps one at a time. First, I need to turn my 47 grams of magnesium chloride into moles of magnesium chloride. And I can do that with the molar mass formula. So my mass is 47 grams divided by my molar mass, 35 plus 35 plus 24, so that's 94 grams in every 1 mole. of magnesium chloride. 47 divided by 94 will give me 0.5 moles. So I'll have half a mole of magnesium chloride. And I'm going to label what this is because I don't want to forget. I'm going to have moles of different things. Step 2, I need to turn these moles of magnesium chloride into moles of HCl. So figure out how many moles of HCl are required if I want to produce half a mole of magnesium chloride. And the best way to figure that out is to use the mole ratio, which is the ratio of the coefficients here. The coefficients units will cancel just like variables will, and they'll leave you never having to guess, do I multiply or divide? So even if you say, oh, I know it's got to be it's either a times 2 or divided by 2, don't take the 50-50 shot. Think about it in terms of the mole ratio. So how do we do that? We've got 0.5 moles of magnesium chloride. We want to turn them into moles of HCl. So in order to cancel, something needs to divide by itself. So the magnesium chloride needs to divide by itself, divide by magnesium chloride. And the coefficient for the magnesium chloride is 1. There's 1 mole of magnesium chloride that's produced every time 2 moles of HCl react. So my magnesium chloride cancels with itself, and what am I left with? Units of moles and units of HCl. So this will give me moles of hydrochloric acid. And the coefficients here tell me what math I need to do. So 0.5 times 2 will give me 1 mole of HCl. So 1 mole of HCl is going to be required to produce 47 grams of magnesium chloride. But I wanted to know what mass of HCl was required. So my last step then is I need to turn these moles into a mass. I'm going to use the molar mass formula for that. I need to get M by itself because I'm looking for a mass. So let's rearrange this. Multiply by big M on both sides. So I'm going to need to take my molar mass and multiply by my number of moles. Now my molar mass for HCl was 36 grams. There are 36 grams for every 1 mole, so 36 grams per mole. Note that I'm not doubling that. There are 2 HCl's here, but I don't need to double my molar mass. I only use the coefficients in this mole ratio step down here. So the molar mass of the HCl is just 36. It's not double that. And then my number of moles here was 1. 1 mole of HCl. So that's math even I can do in my head. 36 grams of HCl will be required. So if I want to produce 47 grams of magnesium chloride, I need 36 grams of hydrochloric acid. So you notice that the mass isn't double here. You actually need a smaller mass of HCl to produce more magnesium chloride. And that's because the magnesium chloride is such a heavy molecule compared to the HCl. The HCl is relatively light, so I didn't require as many of them. So anytime you're doing one of these, you want to follow these steps. First, you need your balanced chemical equation. Then lay out your box diagram to figure out what steps you need to do. Then do each step, right? Show all of your work, track your work, because these questions can get pretty complicated. And then figure out what your final answer is. And we could have worked from the magnesium chloride here to figure out the mass of anything, right? We could figure out how much water was produced, or we could figure out how much magnesium hydroxide was required too. Any of those would be steps that we could do now using this basic stoichiometry method.